Hello, my name is Keith Wolfson. I'm the owner and the trainer or the educator at Pedicomp. Thank you for joining this workshop and for joining the course. I'd like to tell you a little bit about myself so that you know who it is who is conducting this training, this professional development. It's not actually training. My working life was mostly spent in technology and computing, 2/3 of it actually, and then starting off as a computer programmer in the days of punch card coding in a language called COBOL, working for a large corporation, British Leyland and Colgate-Palmolive, moving on to smaller organizations doing systems design, systems analysis, and team leading, and then joining a computer company in South Africa that was a subsidiary of an American company that manufactured local area networking computers in the early days of local area networking. And have done over my time in that area internet design, internet backend programming, multimedia training materials for corporations. And then about 17 years ago, decided that I would like a complete change, and had thought since I was young that I would like to be in school education, and went to the University of New England and did a grad dip ed, and I'm a qualified English and HISI secondary school teacher. And I did 2 years of teaching of English and HISI subjects in New South Wales, some of it in a town called Griffith and some in Campbelltown. And then my love of technology and my fascination with education joined together. Excuse me. I had done a Master of Education in Technology and Education during my second year of teaching and commenced a doctorate in a specific area of technology and education. And I started the company Pedicomp, providing professional education for teachers, the first one being Facebook web design. My interest has always not been in how to teach technology as such, but how to use technology to help students learn and teachers teach in the other subjects, English, maths, HISI, PDHPE, etc. And 15 years, when the New South Wales Institute of Teachers was initiated, they didn't have any technology people doing professional development at that time because it's a very new area, and I was asked to apply to be endorsed and went through the endorsement assessment process and have been an endorsed provider in New South Wales for the last 15 years. For the non-New South Wales teachers, the rules in New South Wales are different from your states. In New South Wales, teachers who also have to achieve 100 hours of professional development have a requirement that 50% of that must be from endorsed providers, provided endorsed by the Institute of Teachers, whereas in the other states, you can select your professional development yourself. You may see me during the session, you will see me looking upwards like this and to the side like that, and that is because I have 3 screens running. The upward one is the one that is showing me exactly what you're seeing on your screens, and the sideways one is the extension of my screen, which has resources that I'm going to be using that I can just drag onto the screen. I want to give you a background on how this course came about, and I'm doing that to actually tell a little bit about it to mainly the primary school teachers, because you have to teach science and technology in New South Wales as one curriculum, and the other states is divided into 2, science and technology. And when we study science, mainly what we are interested in is we have a thought, an idea, and we do research and something that we wish to solve, and our research leads us towards design, and we create a product which satisfies that result. But in fact, a lot of items that are patented and registered don't happen that way. They happen a different way. And the way that I want to illustrate for you is the way the Post-it note was created. Many of you will know the story of that, but in case you don't, and because it's an interesting story to go over again, I'm going to show you an article which explains how the post-it note was created. It's this article over here, and let's just scroll up to the beginning, and I'll zoom out a little bit so you can read it. You can pause at any time, and so I don't have to wait for you to be able to read it. So what I'll do is you can pause it and read it at this point, but I'll scroll down to the end so that you can read the rest of it when you've read that part. So I'll just go back to the top. You can freeze here and then carry on reading the rest. That relates to another slide, which has an example of what I was doing at the time. I was developing a self-study course based in Moodle for Kahoot in a series of workshops. All of my workshops up until this year have been face-to-face, and I ran a series at the time that Bring Your Own Device became the means for students to have devices. I ran one on how to use assessment tools, and at that time included what was at that time a not very well-known product called Kahoot. Some teachers were using it, but most didn't know of it, and gave basic introduction to Kahoot, which is actually sufficient for most teachers to get very good use out of it. And most teachers don't go into the more advanced features, even in the free version. And I wanted to create a course that covered those advanced features. And the trouble with creating a self-study course, if you have a South African accent like mine and you're not skilled in radio announcing, you don't really cover the material well enough for the teachers to be able to attain as much as they could from someone who had been trained in that area. And some years ago, I had looked at whether there was sufficiently good text-to-speech to cover this, but it was not very good, similar to the voice that Stephen Hawkins had. It had improved, but still not good enough. And the other alternative was to hire professionals to do this work, but they are very expensive, and it's very time-consuming going backwards and forwards to get it perfect. I had heard of the developments in deep learning and read of them, and in language understanding, and I decided I would have a look at that, and was amazed, very pleased at what I saw, but also somewhat concerned, I guess, that we'd actually reached this point where the technology would start to impact on work. I did use the technology, and I'll show you an example of the way that I have used it in the Kahoot course by sharing this little 30-second video of a component from that which uses the text-to-speech.
A Kahoot challenge quiz is run differently from a normal Kahoot quiz in 4 ways. Firstly, although the teacher may choose to have the students complete challenge quizzes in the classroom, they are usually completed by the students at home or anywhere else that suits the student. By contrast, classic quizzes are always delivered by the teacher and completed by the students in the classroom. Secondly, in a challenge quiz, the questions are displayed on the student's device, along with the answer choices.
So that was the little segment, and that was my introduction to machine learning and artificial intelligence text-to-speech. And having worked in education and educating teachers for 17 years, 15 of it educating teachers or helping teachers with technology, after a little while of using it, it occurred to me there must be applications for this in education. And I'm sure that it's being used, and I'd like to find out how it is being used, and started doing research and found nothing that I could find on the web about the use of text-to-speech or speech-to-text artificial intelligence in schools or education. Nothing in Australia, nothing anywhere. And I'm not an expert in this area, in learning support and in using this feature. And so I started trying to do research. I thought, well, I can't find any research into a direct application, but what does it involve? Well, it's text and speech to text, the inverse, and it involves multimedia, and started doing research into that. And of course, there's a lot of that. There's been research going on into that for many years, and started to develop an idea of how this could be used. That, I guess, similar to the idea of the Post-it note, that research was my eureka moment. That really, this is quite fascinating, very relevant, and an enormously useful tool. And so I started developing the course. If you're interested in research that I zeroed in on, I read hundreds of articles, and these were the ones that I finally used as my guide on what can we do with this technology. And I'll let you read it in your own time. So you can pause now and read this. And I'll scroll down because we're only seeing 1 to 4. I'll scroll down so that you can read 4 to 7, and you can pause and read this. And I'll scroll down so you can read 7 to 9. And then 9, 10, and 11. And so that's how this came about. And there isn't another course that I've been able to find equivalent to this in Australia. And in fact, I haven't been able to find anything like it in the world. And that is not because I'm a genius. I certainly am not. And it's not because I'm extremely fast. I actually am slow to learn new ideas. It's simply that I came at it from the inverse way, not by needing to solve a problem of how to use of how to enhance student learning using multimedia, but more with a product that I thought this has got to have an application. Same as the Post-it notes story. And as I said, I tell the story for the benefit of the science teachers, the primary school science technique teachers, who can help their students understand that actually you can create things by seeing something and wondering, I wonder if that has an application in an area that I'm interested in, rather than saying, I'm interested in this, let me find something that will solve this problem. We'll move on to the actual course, the actual workshop. This is what we're going to cover, and you can pause and read that, and then carry on with me on the next slide. What is Microsoft Azure, which is the main app that we're using, or the main two apps that we're using come from Microsoft Azure. Azure is actually Microsoft version of a product that these 4 giant companies compete with. There's Google Cloud, Amazon Web Services, and IBM Cloud. And what they are artificial intelligence, machine learning apps that are hosted on and do amazing things on the giant servers that these companies own. And businesses, mainly at this time, businesses use them to perform functions that they couldn't previously perform simply by hooking into these offerings by these companies. They're the only 4 companies, well, they're 4 of the 5 companies capable of doing this. The 5th one being Facebook, but Facebook chooses not to. In my mind, Facebook is probably the most dangerous thing around in the world today, more dangerous than Donald Trump or Rupert Murdoch or the Russians or the Chinese, if you believe that. But because Mark Zuckerberg has a different goal from these companies, which is to make money for their shareholders, but also to provide services that are used, whereas Mark Zuckerberg wants to, I believe, rule the world, if you consider that the way he came to the idea of Facebook was to sexually humiliate women who had refused his advances. But enough of that. We'll move on and have a look at what actually are these apps and what is Microsoft Azure. And on this next page is a brief description of Azure, and you can pause and read that and then carry on with me. I'll move ahead. It's not expected that you read all of this. It's page 1 of a 2-page list of services that Microsoft provides with Azure. You can see the Azure machine learning. We've seen some of that in the 30-minute introductory video. We saw Google's machine learning learn how to beat the world's best player at Go, Microsoft's machine learning in language. That is part of, we're using 3 of these, Azure machine learning, and then language understanding, and also cognitive services, which is behind a lot of this. It's understanding context is a cognitive service. So learning how to speak is machine learning, how to understand language is machine learning, but how to put it into context, it requires cognition. The way Microsoft provides these to business is that the businesses have an app running on their machines, which have data, which may be voice or images or text, and they pass that up to Microsoft and ask Microsoft to process it in a certain way to produce voice or produce understanding of the documentation, receive it back, and then use that. So, for example, the big banks and other big organizations have started looking at this, and they may be using it. You may not be aware yet. I think not, because the accents are not yet Australian, but they can reach an agreement with Microsoft that what they will use, they will use Microsoft's text-to-speech to simulate human voice, and use Microsoft's cognitive services to analyze all of their documentation on how to provide service on a certain function that people might call in about. What is happening with my account? Why have I got an overcharge? How do I open a new account? And Microsoft cognitive systems can deep learn the content of Westpac's documentation and come to a point where they can provide superior telephone service 24 hours a day compared to the human beings currently doing it. A very worrying development, a wonderful development, and very worrying at the same time. Wonderful in that it allows much more intense understanding of material and people to access it easily using speech, but worrying from the point of view, what does it mean for future work and jobs? So back to what we're covering, and in the text-to-speech section, these are the different items we're going to be covering. So you can pause and read that, but I'll move on so that when you finish pausing, you can carry on with me. The first one we're looking at is the text-to-speech, Microsoft Azure's text-to-speech. And I'll move on to the next slide. The way Adobe Connect works is similar to PowerPoint, except these slides are actually complete meeting rooms with resources and functions and activities, and I see the list down the right-hand side of my screen. You can't see them. It's like a PowerPoint slideshow, and I can select the next one. And here we are. We're going to open that Microsoft Azure text-to-speech page and look at it, and I'm going to use the file on the left-hand side called What is a Solar Eclipse? Those people using what I call the Adobe Connect intrinsic system app to watch this, that is, you're actually using Adobe Connect to watch it, can download these files simply by clicking on them and selecting download. We're using only the what is a solar eclipse at this moment. We'll come to heteronyms next, or actually 2 steps ahead. And also, if I select the link in, we'll examine Microsoft Azure's text-to-speech, and you can't see this on the screen that I'm actually selecting it, and select copy, where at the bottom it says web links reused. If I paste that into there and select on my screen, it says browse to, it opens it for me behind the scenes, but it will also do it for you. Even though you're watching this later, a replay of the recording, it uses the app that you're using to watch it to automatically open it for you, so I can save you the trouble of copying it and typing it in. So I'll do that now, and you'll see that if you're actually watching on Adobe Connect, the browser will miraculously open at that page. Those using the video, you have found that I have included files in the page that you link to the video from, and amongst those files are 2 Word documents which contain these links for part 1 and part 2 of this workshop. So I'll open this for we Adobe Connect viewers, and the people in the video can open it themselves, but you don't need to open it yet. I'm going to take you through it and show it to you, and then you'll try it for yourself. So I'll select open, and for me and for the Adobe Connect people, that has opened. But for those people for whom it has opened and obscured the Adobe Connect screen, please return to the Adobe Connect screen so that you can follow me as I show it to you. I'll share my screen with you, and I do that by enlarging the share my screen view, which currently says nothing is being shared for you, maximizing it, and then sharing the screen. And here we see the page that has been opened, and it is the speech to text page, and I'll scroll to the top. And you'll see on the left-hand side is a green button which says Start Free. Don't click on that. That is for those people who have these programs of their own, and they want to experiment with linking Azure into their own programs by creating special program links. We're not interested in that. We don't need to do that. And if you click on Start Free, it's going to ask you for a credit card, and you get 1 month to experiment with it and decide if it's for you. If you don't like it, if you're a business and you decide you don't want to, you need to terminate your 1 month subscription, because after 1 month, you're automatically charged for it. It's not expensive. I think to do perhaps 10 pages of converting text to speech might cost you $1. But to do that, you have to be an expert. You have to be fairly well versed in programming, probably in a language called Python. So don't click on that. Do what I'm going to do and simply scroll down, not at the moment, but when you do this yourself, until you reach this box over here. This page has been set up by Microsoft to enable people to experience for themselves what it looks like. And they have created this part for businesses who don't want to yet experiment with the actual hands-on integration. They just want to see how it works itself. And this is a wonderful tool for us. It's free, there's no fee for it, and we can actually use it as a fully functional text-to-speech utility. I'm going to copy the text that I want to use rather than their simple voice. It's in a document called, that document, What is a Solar System? Sorry, what is a solar eclipse? And I'll copy it and paste it. And let's just see what it sounds like without making any changes. I must admit I'm sometimes concerned that can you actually hear me? Is this working? Yes, I can see my microphone is working, so you are able to hear me. Good. Just make sure it is the Yeti. Yes. Good. On my screen on the right-hand side, I have monitoring the sound whilst I'm talking. So we won't modify any of these sections on the right-hand side. We'll just select play.
What is a solar eclipse? Sometimes when the moon orbits Earth, it moves between the sun and Earth. When this happens, the moon blocks the light of the sun from reaching Earth.
Right. So we can hear that's an English US accent, and she's talking quite fast. Let's switch to the Australian accent. So if we click there and select English Australia, what this on the right-hand side means is what accent should I use when I create text-to-speech. But I guess from Azure's speech to text-to-speech point of view, it's more than that. It's actually what language are you speaking? Because by telling it what language you're speaking, and I get what it's like dialect, or it's more than an accent, it's actually a dialect. It will try to understand the context of what we're saying. So if we try to listen to it in French, it would sound like a French person speaking it, but it would not have much knowledge of context, because the context is within its understanding of English. And we'll hear that it understands, that it's able to speak as if it understands the context. So I've selected English Australia. Let me point out these voices. Under voice, when we select English Australia, there's Natasha and William, which both are neural, and Catherine and Haley. They work completely differently behind the scenes. Natasha and William are the voices that have been created by Microsoft in the way that you saw on the 30-minute video in the Microsoft animation of how their deep learning works with languages. And so these ones have not been taught anything about phonemes or phonics. They've not been taught about punctuation. They've simply been fed huge amounts of text with huge amounts of voice that are recordings of those texts with a giant variety of people. And they have been told what the ideal Australian female voice looks like, which is probably what an ABC news announcer, I guess, sounds like in Australia. Natasha has been around for some months, since the beginning of the year, actually. William is fairly young, and Natasha has been through much more learning than William, and if you try them both, you'll hear Natasha is actually better at understanding text at the moment, as I would put it, than William. But William will catch up quite quickly as they feed William giant amounts of data. Catherine and Haley are the old type, and these are created by brilliant people who understand phonics and phonemes and etymology. It's hard to teach context, so this doesn't cover context because you can't teach context in a program. It's too difficult. And but it does understand punctuation. And they're the old style of doing it, and they still remain there, but we'd probably choose to use the neurals. So I'll play this first using Catherine.
What is a solar eclipse? Sometimes when the moon orbits Earth, it moves between the sun and Earth. When this happens, the moon blocks the light of the sun from reaching Earth. This causes an eclipse of the sun, or solar eclipse.
Right. Now let's listen to Natasha. Sorry, it's still English Australia, but instead we'll choose Natasha.
What is a solar eclipse? Sometimes when the moon orbits Earth, it moves between the sun and Earth. When this happens, the moon blocks the light of the sun from reaching Earth. This causes an eclipse of the sun, or solar eclipse.
I want to move on because when Natasha's speaking that fast, it doesn't really sound as if she understands what she's talking about. So let's have a look at speaking speed. My preferred speed for Natasha is 90. And I'll play at 90.
What is a solar eclipse? Sometimes when the moon orbits Earth, it moves between the sun and Earth. When this happens, the moon blocks the light of the sun from reaching Earth. This causes an eclipse of the sun, or solar eclipse. During a solar eclipse, the moon casts a shadow onto Earth.
So I much prefer that because it is sounding more as if Natasha is understanding what she's reading as she is reading it. And there's more meaning put into it, and she is very good and improving. This ability to modify speaking speed is enormously important for us as teachers in using this to support reading learners. And this brings us to the work that John Sweller, the gentleman, the researcher who you saw towards the end of that 30-minute video, the work that he has been able to do and is recognized worldwide for. It builds on what earlier researchers found about how working memory works. And what they found is that working memory actually has two different memories and two different channels: auditory memory and visual memory. In fact, there are possibly three memory areas and three channels because we also experience the world kinetically. Those are the three ways we absorb information: by sight, by sound, and by touch. But kinetic working memory does not feature in any research. I haven't actually looked into that yet, but it's an area I'd like to research more. There's only a small amount of working memory available in the human brain for sound and for visual, and they're separate. In fact, they're separate channels and separate areas. They're very fast. We developed the speed at which they function. We developed them as we developed as Homo sapiens, and they've always been part of our ability to understand and exist with and interact with our world. However, reading is very new. In fact, in many parts of the world at the moment still there are many human beings who are not able to read. And it's only in the last 150 years that it has become a general skill. 150 to 200 years amongst the general population. Before that, there were very few people who knew how to read, select people. And reading actually uses both parts of working memory, because what has been established is that when we read, we translate the text into words which we hear in our brain, and we then analyze and understand those words. So we use the visual working memory to do the translation into sound, and the sound working memory to understand that sound. It's a two-step process. What John Sweller found is that if we have the in read along, or any time when both are being used simultaneously in the human brain, so perhaps a child is reading along with a student, but with a teacher, both reading aloud, or two students are reading together, one reading aloud, the other listening along. If the audio is going too fast, the reading and interpreting student will suffer cognitive overload. That is, their processing of the text into audio and then understanding the audio won't be able to keep up. If it can't keep up with the voice they're simultaneously listening to, they are not able to process at the same speed. And in fact, what happens is they learn less, achieve less than if they were only reading the text or only listening to the audio. That, of course, does not mean that reading along and reading along aloud is not good. It certainly is beneficial. But it tells us that we have to be very careful and individualize for each student the speed at which the audio is moving, so that it doesn't overload the student's progress in interpreting the text and translating it into audio in their working memory and understanding the audio. Why is this so important in this app? Because how do we do that otherwise? It sounds false if we try and do it ourselves to some extent, and we can't keep the pacing that well, but there are skilled people who do it. But another way that it can be done is by slowing down the audio, but that is a terrible way of doing it, because if I'm saying I am now speaking at a normal speed and then I slow it down, it sounds like I am now speaking, because the pitch changes. But in this app, we can change the speed without changing this pitch. And we can slow it down to whatever speed is appropriate for the child who is using it.
What is a solar eclipse? Sometimes when the moon orbits Earth, it moves between the sun and Earth.
I'll move that back up to my favorite 90. And let's have a look at pitch. Pitch changes the wavelength and deepens or raises the timbre of the voice. So if I reduce pitch down to perhaps 70, this becomes a much deeper woman's voice.
What is a solar eclipse? Sometimes when the moon...
And we can make it very deep.
What is a solar eclipse? Sometimes when the moon orbits Earth, it moves between the sun and Earth.
This has more utility than trying to make the voice more attractive. I prefer in here this as well, the 90 voice for Natasha, and this is my standard for when I'm recording text-to-speech for my self-study material. I have a standard where I use Natasha at 90 and 90. And this is also very useful for you, because what we don't want in students engaging with our material is that each one they engage with is slightly different from the other, because that also hijacks working memory as it tries to compare it with what it knew before and monitors the difference. We'd like to have something that is standard, that becomes habit and doesn't therefore hijack what we're trying to use for other purposes, that is the student's working memory. But where it is useful is that the student, another way it's useful is that the student, if they're using this, and it's so easy to use, they can easily use it themselves, can record, if they like, in a child's voice rather than in an adult voice by pushing it up. So at 24, 1.24 times the standard rate. Now I'm glad that this has happened. What you can see is that when I click on play now, it's not working. And the reason is that if I don't use it for a certain period of time, I'm not sure, I've not measured the period of time, and it varies depending on how I'm using the interface, the web page will cut itself off from the Microsoft servers. And that's easy to solve. I just refresh the page. But if I have material in this field that I want to keep, I need to copy it first before I refresh the page, because otherwise, when the page refreshes, it will be gone. So now I'll refresh the page and repaste the text. But notice also that it resets the defaults to US, Jenny, and resets the speeds. So I need to reset those to what I want, which is English Australia and Natasha, and the speaking speed of, I had 90, and the pitch I was going to experiment with 1.24 or 2.5.
What is a solar eclipse? Sometimes when the moon orbits Earth, it moves between the sun and Earth.
And we can have an even higher pitch if we want to experiment with it, but when it gets too high, it starts to sound artificial.
What is a solar eclipse? What is a solar eclipse? Sometimes when the moon orbits Earth, it moves between...
But it is useful that way to allow students to have a model, a standard for recording in a child's voice. You'll notice the final thing I wanted to point out was it says at the bottom, note, your data will not be stored. Your data is sent up to the Microsoft servers to be processed and returned to you as voice, but they don't keep it. It's discarded immediately. There is no point in their keeping it and paying for storage capacity on their own servers. However, if you are a business using it, you can select to have your data stored on their servers if you want to come back and use it later on. I'm going to return to our Adobe Connect page, but I invite you now to experiment with this yourself so that you can get used to it. We'll come back to the SSML tab later, but for now, I'll go back and you can pause the Adobe Connect part and experiment with this. We'll continue with the next section. So we've covered Azure text-to-speech as an introduction to Azure. Now we'll look at how do we record that speech that we have generated, because that's the main use we're going to get out of this, creating something that we can use in another area. And I have a series of slides here that guide you through this process, and then I'm going to demonstrate it to you and then give you a chance to try it for yourself. To record the text-to-speech, we're going to use an app, and the app app I'll demonstrate and that I recommend you use is an app called Audacity. I'll tell you a bit more about Audacity when we get to it. And what is happening is our computer is generating audio, which we heard, and it's routing that audio back into itself so that Audacity can use the internal microphone to record it. And so to do that, we have to interconnect our output socket, our audio output socket, with our audio microphone input socket. On a desktop, that's easy to do because desktops always have both of those, the headphone and the microphone. And so we simply take one of these loop audio cables and plug one end into the earphone and the other into the microphone. On laptops, that is different because laptops invariably don't have two sockets, they only have one. On many laptops, that is only audio. On some laptops, it can be used either as audio or as microphone. When you plug something in, it will try to detect what it is, or it'll actually ask you whether you want to use it as a microphone or as speakers. But it can't do both simultaneously, and that is what we need. We need the computer to be outputting audio and recording that audio at the same time. operating both a speaker and a microphone. And that is why I suggested in the confirmation email you received that you would think of acquiring one of these very inexpensive little devices with the device and the loop cable. It's under $10, including postage. And that simply is an additional 2 audio sockets, 1 microphone, 1 speaker. And when you plug it in, your computer automatically recognizes it and makes those 2 new audio sockets available to you. And that's what we're going to use to do our speech-to-text recording. And we'll see how that works, how we actually tell the computer which audio sockets we wish to use. In fact, we're going to look at that now. We're going to go and set having plugged that USB speaker card. It's called a card, even though it's a USB device. We're going to plug it in. We have plugged it in, and now we're going to tell the computer to use that. And to do that, we right-click on this area over here. Oh, you can't see it because you're looking at, I was going to show it to you on my computer, but you can't see it because we're all watching the slide. But I'm showing you with the arrows where you find it on the bottom right-hand side of your screen is the speaker icon, and you right-click on it. And that opens the window on the left. This is a before and after. So on the left is before you click on the setting to change it, and on the right is what you're going to see. So whatever is your current output device will be shown on the left here, and when you click on it, you'll see it and whatever you have. You might only have one. I have my Sony TV attached as well as an audio device, so it's showing that. And what I want to do is I want to switch it to the USB audio device. You probably won't see a 3 in front of that because I have had a number of, I've plugged these in and taken them out and plugged these in, and there've been times when there's been more than one, and so it's gone and numbered them so I can differentiate between them. So what I'm doing here is I'm setting my output device to that, and I do the same for the input. I set it from what it currently is to the USB. And now I'm telling the computer what I want you to do is output through this audio USB and record through the audio USB. And unbeknown to the computer, it doesn't need to know, I've interconnected the 2 with that cable. Having done that, I need to do a test recording to make sure that the volume setting is correct, because if it's too loud, I'll get distortion, and if it's too soft, we won't be able to hear the recording. And this is how I go about doing that. I start Audacity. Now, I'll tell you a bit more about Audacity when we actually get to open it. But what I need to do is tell Audacity that I'm using this USB card now. So because I've done this before, mine already knows that it should USB, but yours may be set on the previous default, and you have to switch it to tell Audacity by clicking on the little drop-down arrow here. By clicking on that tiny, you can't see my screen, I forget that. By clicking on the tiny little drop-down arrow at the right-hand side of the words that say microphone audio, that will give you the chance to select the audio you wish to use. We don't need to select the output at this stage because we're only interested in recording. We're not interested yet in playing back the recording, but we'll have a look at that when we do it. And I always start Audacity first to do the recording, because if I start playing and then start recording, the web page will detect that I've jumped off the web page and stopped playing. And so I press the record button on Audacity, and then I go to my text-to-speech and I press the play button, and I see the wave starting to appear in Audacity, and I adjust the volume by sliding the volume adjust setting, and I'll show you that when we're on Audacity. And I've shown you the examples of where it's much too loud. You get what's called clipping, where the waveform is hitting the edges and you get severe distortion. Then if it's much too soft, it looks like the middle one. Sorry, yes, the middle one, and the bottom one is the perfect waveform. That's what you should aim for. When you're satisfied you've got the perfect waveform, you select stop. The stop button to end the recording. And we don't want to keep that recording. It was just a test recording. So we click in the light blue area to the left of the waveform, which selects it. And we press our delete key and it's deleted. Still playing, we press its stop button. Excuse me, I paused the audio so that I could cough there. Now we're going to do the actual recording, and of course it's virtually identical. We press the record button to start Audacity. We select play to start playing Azure. And we monitor whether it has finished playing or not. We can't tell from Audacity whether it's finished playing because Audacity is just showing us a waveform. But we look, let's go back, we look at the text-to-speech, and what will happen is whilst it's playing, that blue play button will turn to a stop button in case you want to stop it. And when it's finished playing, it will turn back to a play button. So we monitor whether the blue button is saying stop, and when it becomes play, we know that we've finished recording and we go and stop Audacity. We'll also see that the waveform in Audacity becomes empty. We now want to save the recording, and we click on File, and we don't select Save Project. That will save it as an Audacity project. We want to export it as a file, and so we select File and Export, and invariably we want to export it as an MP3. So that's the process that we go through, and I'll now do that for you so that you can observe how it actually looks in practice, and then practice it for yourself. I'll share my screen with you. So text-to-speech is already open, and I'd like to be able to view Audacity and text-to-speech alongside of each other, so I'll restore text-to-speech down so that it occupies half of the screen. Actually, I prefer it so that I can see the play button there, so I don't want to make it too narrow. And I'll open Audacity. Audacity is part of the standard rollout platform for devices in all of our states. It is actually, I'll open it first and tell you more about it. As I was saying, all of the states have it as a part of their standard platform for the devices that they're using. And it is a free app, but it's a very powerful audio editing and manipulation app. To become competent in using all of its features will take some time and some practice, but for what we're doing, one can actually pick that up in a few minutes. So we're going to do the test to get the audio right. Now, what I should have done, excuse me, what I should have done, but what I would normally do, as we saw in that series of slides, which you can go over again at any time to refresh your memory how we do it. What I did first was I set the audio to the two USB devices. I can do that now for the speaker, but if I do it for my microphone, you won't be able to hear me the moment I do that, because it will cut off my desktop microphone and you won't be able to hear me through the USB device. But let me do it for the audio, for the speaker, so that you can see what I'm doing. And I right click on the speaker icon and select sound settings. And I already have sound settings open, but so I'll drag it over, and this is the window that opens. And this I can do without cutting you off. I select the output device I wish to use, and there you see speakers, USB audio device. So now any output from my computer will not be heard through my computer speakers. It'll go through that audio. And what I would do next is I would change the Yeti microphone to USB audio device. Let me tell you what I'm going to do. I'll do that next, but first let me tell you what I'll do after that. So what I'll do is I will change that to USB, but I need to have Audacity closed until I've made that change. Because even though we can tell Audacity at this point that we want to use that USB audio device, unless it is the default device at the time we open Audacity and tell it that we want to make the change, it will not use it successfully. So I have to close Audacity. I opened it to demonstrate to you, but really the steps that I have to follow are: first, change the audio settings, then open Audacity and change the selection or set the selection of the audio. And then I do my testing in Audacity, and then I do the actual recording. So that's what you'll see me doing. Next, I'm going to go and change the audio selection to the USB, open Audacity, do my testing, and then do the recording. What you may see when I try and do the recording is that we will have been cut off again from the web page and the backend servers, and so I'll refresh the web page and do the recording then. So here I go. I'm going to open that sound setting again, and when I switch this over to USB audio, you won't be able to hear me anymore. But as soon as I finish the recording, I'll switch the microphone back on to discuss what I did. I've switched my desktop microphone on so that you could hear what I'm doing. I had actually stopped the playback, but I neglected to press stop on the Audacity recording. So just to give you a couple of little things which aren't in the documentation, you can look up the documentation for Audacity and say, how do I zoom in or out? And you can select view, zoom out, because I want to delete that extra part, but also pressing the control key and the 3 key, I think it is. Sorry, it's shift and 3 will allow me to zoom out as well. And I can just select what I have over recorded and press delete. I mean what I recorded that I didn't really want. And if I want to delete that extra bit at the front, I select it and press delete. Now, of course, I didn't record the whole thing because I didn't want you to have to sit and wait for me to record it. But the last step, as we saw, was to save it, and so I select File and Export as MP3, and select where it is I'd like to save it and change the name to whatever I like, and select Save. And there I have successfully done my recording of my text-to-speech. I'm going to return, what if we want to play it and hear what it sounds like? Well, in that case, I need to change my microphone, which currently, my speaker is currently still set to the USB speaker device, and I need to change it to my to the speaker I want to use, which is the Connectant. And there you heard that change was successful by the little ding on the sound. But what I found with Audacity, I don't know if it's just on my computers, but I think it's the case with Audacity. If I try and use that, it actually won't play it. I can see that I can see from the audio here that it is playing. It thinks it's playing it, but it's not getting through to the speakers. Now, I could try and analyze why that's happening and fix it, but what I found invariably works is instead choose Microsoft Sound Mapper, because Audacity is able to see what the Windows system has currently set as its preferred device, and that will overcome problems of, for some reason, things not working. So if I select Sound Mapper, that will work.
What is a solar eclipse? Sometimes when the moon orbits Earth, it moves between the sun and Earth. When this happens, the moon blocks the light of the sun from reaching.
And there I've been able to hear what my audio sounds like. So as I said, I will return to Adobe Connect, but invite you to experiment with this yourself. And when you have completed that, then return to Adobe Connect and select to continue with this workshop. I'm going to carry on to the next section. We've created a recording, and now we'll look at SSML. What is Azure SSML? As we see here, SSML stands for Speech Synthesis Markup Language. We'll use a couple of slides to try and explain that. What is a markup language? And I think probably the easiest example to understand a markup language is using music, what we might call music notation. When a composer writes a piece, they start off by writing notes to represent the notes that are required to be played. But the composer wants some notes to be played loud, some soft, wants a change in perhaps in whether notes are played together or played separately. And that is done by adding notations on the music sheet to give the player advice on how different sections and different notes should be played. So we might call that markup, where we're marking up the sheet to explain how to play certain notes. And with speech synthesis, it serves the same purpose. So here's an example of SSML markup, where it is advising the synthesis system on how to pronounce what is being turned into speech. So we see here, how do we escape from this room? Are we going to die? And there is some markup saying we need pause for 300 milliseconds. Then prosody, which determines how the speech is delivered. And here it's telling the synthesis language that it wants the voice to be raised to a higher level, and instead of saying, no, we're not going to die, it would be, no, we're not going to die, and so on. We're not going to look at the complex areas. We're not going to look at these. What we're more interested in is what the next slide is showing us. and that is how you can use SSML to tell the synthesis how you want the word pronounced, what phonemes you want to have comprise the word. So here, the part in brown is what I've provided. So if we wanted to tell the computer, the synthesis language, how we wish that word ADD to be pronounced, we would use the standard SSML definition. And the variable that we would change is the part that says AHDD, and that is telling it what phonemes we want pronounced, and together those would sound like add. That might look a bit complex to use, and it is, but I've created to some extent, it's an easy to make little mistakes where if you forget a bracket or a slash and then have to try and find them because one mistake will cause everything to not work. And so to simplify it, I've created a table that automates it for you. Actually, it's not a table, it's an Excel table that automates it for you. But let's have a look at the Microsoft phoneme table. And that gives us an idea of what are the different phonemes that we actually wish that we can use. So here, the table is on the left-hand side, and I will maximize it so we can see it easily. The phoneme table for English, and it has a vowel section and a consonant section. We'll look at the columns. The first column is UPS label, and you don't need to concern yourself with that. I put it in so that you can understand when you see something talking about UPS. There are a number of standards that dictate how synthesis apps work, and the most widely used standard is UPS. One might compare it to a standard for Braille, and my understanding is there's only one standard for Braille, but perhaps when the idea was first thought out, there could have been different standards and different ways of representing Braille imply different words, but fortunately it became one standard. So you might see the UPS item somewhere, but ignore that. You don't need to be concerned with it. What we are after is the example word and the UPS transcription of that word. So I've highlighted in red the phoneme on the left in the word, and on the right the code for the phoneme that you have to provide in your SSML. So if we wanted to pronounce the phoneme O as in pot, it would be AA. A as in fat is AE, A as in bug is AH, and so on. Where the word has two vowel phonemes, I've highlighted both of them. So I as in driver is AI, and as in driver is AX. Those are the vowel phonemes. And under consonants, the same thing. The consonants are somewhat easier because often the phoneme is actually the letter that denotes it. So as in button, N in button is an N, and a B in button is a B. Those are all the consonants, and all of those together make up all of the phonemes in the English language. The table I created this from also had a section on prosody, which is how do we want that word spoken, and I'm not going to cover that. It's a more advanced area, which if you want to start using SSML more extensively, then you could go and look up prosody, but I included it for because it's actually part of it, but I'm not going to cover it. We'll move on. And look at how do we actually then, if we understand that there is this facility to modify phonemes, how do we go about doing that using SSML? This is where I'd like to use the document that I suggested that you should download, the heteronyms.txt document. Heteronyms, as we know, are words that are always spelt the same, but they are pronounced differently in different contexts. And here's an example. He moved towards the present podium where the awards were given. She moved towards the present box where the wrapped gifts were. That one, many people reading initially would, I guess, read the first part and say he moved towards the present podium, but when it said where the awards were to be given, would realize, oh, it should be the present podium if that's where the awards were to be given. I think that most speech-to-text languages would have a difficulty with that one as well. But heteronyms give us a good chance to see how well is the speech-to-text actually working. And so I'm going to pause and copy that heteronyms.txt. Actually, what I've done is added it to my screen, so I'll share my screen with you and you'll be able to see that and our use our use of, or our analysis of how heteronyms tell us whether we need to use SSML. So I'll share my screen with you. And there you can see the file of heteronyms. My screen's getting a bit busy, so I'll close Audacity and select some of those heteronyms. I don't need all of them. Return to speech to text. Sorry, text to speech. Now I think probably I've been cut off from the servers. Let me test that. If I select stop and it immediately returns to play. So yes, I need to refresh this again. And insert my heteronyms. Select my favorite voice, which is English Australia, and my favorite speeds, which are 90 and 90, my pitch 90, and play these heteronyms. And I'll comment on them as they're played.
A rebel is one who has decided to rebel.
Got that right?
Everything I know I learned from that learned old man.
Good.
Extreme weather made desolate a place, making it a desolate place.
So that one, it didn't get right. It should say extreme weather made desolate rather than desolate a place, making it a desolate place. So Azure's text-to-speech as yet is not able to correctly discern that context. And I would suggest that in a month or two's time, I'm not sure how long it would take, but it will get it right. Let's listen to some of the others. I'll delete the first because it always starts from the beginning again.
Hopefully the wind will be strong enough to wind the windmill.
And that should be hopefully the wind will be strong enough to wind the windmill. So let's use that one. We're going to use that one as our example of how do we go about manipulating the phonemes so that it says hopefully the wind, just let me remind myself what it's saying.
Hopefully the wind will be strong enough to wind the windmill.
And we'd like it to say, hopefully the wind will be strong enough to wind the windmill, which will give us an introduction into phonemes and also into how we might use the facility to manipulate phonemes in helping students learn phonemic awareness and other aspects of reading support. So I'm going to return to Adobe Connect to show you the next slide. We'll now look at the Excel table that I've created that allows you to easily manipulate phonemes in Microsoft Azure Speech Synthesis Markup Language, or SSML. You'll see in the files list at the top left-hand side of the screen the file SSML phoneme creation tool.xlsx. That's one of the files included in the files folder in the Moodle course page above the link you selected to access this video. The files open on my desktop and I'll share my desktop with you so I can explain the Excel tables in the files to you and show you how to use them. Here is the Excel workbook, and as you see, it contains two tables. I have it open on the SSML phoneme table, which we'll look at first, and then we'll look at the SSML builder table. This SSML phoneme table is an Excel spreadsheet version of the Microsoft Azure SSML phoneme table that we looked at a little while ago. But I've enhanced it to make it easier to use in this context. So you'll see there are some notes in the top few rows, and then the first section is vowels. We'll see lower down the table is the consonant section. The first column contains the example word used as an example of the phoneme denoted by the vowel highlighted in red. The next column contains the phonemic representation of the whole word in Microsoft Azure's SSML. And then the following columns break that down into each of the SSML symbols or codes for each phoneme that goes into constructing the word. So, for example, the word pot is used as an example of the phoneme O. The table has been secured so that nothing can be deleted, but the SSML codes can be copied and pasted, which is, as we'll see, used when we look at the SSML builder table. So if you want to copy the phoneme for O to put it into the other table we're going to look at, you can click on the AA and select copy, either by Control-C or selecting copy. So these are all the phonemes that we're going to be using. Let's have a look at the SSML builder, and it explains up at the top how the SSML works, so you can pause and read that for yourself. Part of it needs to be realigned. I see the SSML that makes the sound of your word, that needs to be realigned. But it's instructions on how to use it. What I've done is on the left is a free entry place where you can place the word that you wish to create. And the word we wish to create phonemes for is wind. It's pronounced as wind, but we'd like to say it as wind. And what we need to do, and you need to do, or the student needs to do, is we need to enter in here the phonemes that make up the word wind. And the way we do that is we go back to the table and we start identifying them and entering them there with a space between each one. So first we need the consonant for W, and here it is W, and it's a W. So I'll go back and put in W. They're required to be in uppercase, but what we'll find, and I press enter so that it remembers it, is that I've also included code in this so that it will translate incorrectly entered lowercase to uppercase. So you don't need to be concerned that your students might enter the lower instead of upper. It will convert it for you. So we need R, I, W, I, ah. That's not Y, I, N, D, wine. That's a difficult one, but let's see if we can find it. So let's see if we can find the three others rather than jumping backwards and forwards. We need and. So I, vowels, they're high, I, so it looks like AI, and then find N, should be N, chin, N, so AI, N, and D is D. So AI space, N space, D. Students, you might have your students do that one at a time to start off with, but AI space, N space, D, enter, and you can see it has placed it into the phoneme alphabet area. Creating that very specific line of SSML without having to go through the complexity of putting in the left bracket and the right brackets and everything else that's required. And all you do now is you copy that and return to text-to-speech, Azur's text-to-speech. I'll just make sure that I haven't been disconnected yet, so I'll select play.
Hopefully the
No,
wind
I haven't been
will be strong enough.
disconnected. Now I'll delete the rest for now, just so that it looks, so that I can concentrate on what I'm doing here. And we remind ourselves currently it said,
Hopefully the wind will be strong enough to wind the windmill.
and we'd like to change that second wind to wind. And this is how we go about doing that. We're now working with SSML. So when we select on SSML, we're shown the SSML that behind the scenes is making this page work. At the moment, it's fairly simple SSML. I'm not going to go into that because we don't need to do that. If you read through it, you'll probably get to understand it. But what I always do is where the lead in SSML ends at the end of that right angle bracket, I put a few spaces, sorry, not the bracket, and at the end as well, just so that I don't accidentally go and change the SSML itself. If I start working within the SSML and I put in something that has its own brackets, it's too easy to get confused and change the wrong thing. So I do this so that I can ignore the top SSML and the bottom SSML, which is just, the top is telling it the basics of what is expected of it, and the bottom is telling it that we're now finished. But what I do is I'd like to replace that second wind with what I created, which was wind and copied. So I place it in, and let's hear whether it's fixed it or whether it's pronouncing it the way I want.
Hopefully the wind will be strong enough to wind the windmill.
Yes, I got it right. So that's what we're wanting to achieve. A very simple way to manipulate the phonemes using SSML in text to speech. Let me show you a fun way that you could do this with students. So my granddaughter plays around with this, and she's only 9 and has fun with it. And so it certainly can be mastered by students. It's very easy. It looks complex. It's very easy. We might say to our students, I'd like you to draw and then invent a name for a fake animal. And try and write the name the way you would like it spelled, but we'll work out. You can write it as you think you want it spelled. You can decide what the spelling should be, and then we'll say what it is. So my animal, I think it's going to be a wobby-dook. A wobby-dook. So let's hear what that sounds like in speech to text. So I'll copy it and go to speech to text. And I'll put in that word. Hopefully the wobby-dook will be strong enough to walk home. I don't need that phoneme anymore. I'm just going to make walk home. And we'll hear what it sounds like.
Hopefully the wobby-dook will be strong enough to walk home.
Okay, I wanted wobby. Let's see what we can do with text-to-speech. So I have to find what W is, and I know it's W. And how do I say oh? I'm going to go back to there and find an oh. And it's pot, so it's A. And B is B. I know that's wob. That's enough for now. I don't want to get too far ahead. So A and B. Wa, A, B. And then E for Rob, E. And then Duke. So let me find E. not as in whistle. It's E as in ink, which is IH. E, and then I know it's do, so let's do those two. So it's IH, D. And how do I say ook? Well, what is the phoneme representation for ook? There's food, and it's a U. U. And let's find a K. K as in king, it's K. Press enter. And let's see if I've created the word Wabidook. Back to SSML. And let's say Wabidook. Well, I'll just put it straight in. Just place Wabidook.
Hopefully the Wabidook will be strong enough to walk home.
Ah, wow. But didn't I have... Oh, now, this is not working as I hoped. This we should regard as an asset, not... If it worked immediately correctly, then there's no thinking required. No thinking about what is happening with the way that this is written, with these phonemes, how I would spell it, how I would write it. But it's not done what I wanted. It's saying wa instead of wa. Let me see, did I transcribe the correct thing? I go back to the table and look up oh. No, it's lo, oh, long, A-O. Ah, it should be an A-O. Let's try that. So what I could do is go straight to the phonemes, the SSML, but it's better if I do it in here from a learning point of view. And that should be A-O, A-O. Select it. Go back to the speech to text and replace that with the new one. I'd like this back on the same line. And let's see if that sounds better. I've lost contact with it, so I just select that, Control C, refresh it. Now, working in SSML, I can completely ignore the right-hand boxes because what I've done is I've copied what was in the right-hand boxes before. When I did my copy, I actually copied the instructions guiding the right-hand boxes. So the SSML overrides what is ever in the right-hand boxes. And so by doing a copy of SSML and a paste of SSML, the fact that on the right-hand side it says English US doesn't matter because here it says voice name English AU Natasha, and that will override this. In other words, when I'm working in SSML, I don't need to reset the right-hand side. I just copy everything that's on the page and replace it, and that is what, and that will work. So let's see if I've got it correct this time.
Hopefully the Wabidook will be strong enough to walk home.
Oh, Wabidook. And so I'm not going to carry on working through this and try and find the right answer because that's not my goal. My goal is to show that through this adventure and exploration, we're helping students to get a handle on, to understand phonemes and develop phonemic awareness, and how the way we might have spelt it is not the way that English would actually say it. And it seems to me a great tool for augmenting what we currently do in teaching phonemic awareness and helping learner readers and struggling readers to understand how to implement and to, I guess, understand what the way phonemes work in reading in the English language. I'm going to once again go back to the Adobe Connect page, stop sharing, and invite you to play around with SSML and the phoneme creation tool. And when you have completed that, then we'll continue. You can come back here and continue then. I'll move on. The next section we're looking at is OneNote optical character recognition. How does that fit into text-to-speech? It is because there are many documents, books that we don't have available, legacy books that we don't have available in we don't have available in text form, in manipulatable text form. They're available as images. They've been scanned. And times will arise when we'd like to use those. And how do we get that into a textual format that we can put through text to speech to create audio from? Because what we're using this for is to create another medium in which to transmit, in which to convey this knowledge or whatever it is we're working with. We're using audio as the medium, and this gives us the ability to convert text in an image into text that can be put through text to speech and create an audio medium. And the tool that is powerful for this use and the one that works well is OneNote, Microsoft OneNote. So this is taking you through the steps that I went through to do this in OneNote. I found a document that had text in image form, enlarged the text, and I used Microsoft's built-in text copy facility. What it is just, you can see on the left-hand side there, the keystrokes. I pasted them over this image so you could see. You hold down the Windows key and the Shift key and select S. And that grays out the screen, and you're invited to draw a rectangle around the portion that you wish to copy as text. And that's what's happened here. You just can't see the cursor drawing the rectangle, but here I've used Windows key Shift S and drawn a rectangle. And when you let your mouse go, that then is in memory. And if I go on to OneNote and paste it into OneNote and right click on it, one of the options is copy text from picture. And there's the text. The reason why I created this slideshow rather than show it to you in real time is because this computer, of all of the different computers I use, for some reason does not do that. All of the others do, and this is the computer I use for my Adobe Connect work, and so I can't show it to you working. But if you try it for yourself, then it will work. I'll move on. And I wanted to show you another facility that does that, and it does it with web pages. When you're looking at something on a web page that you would like to work with as text, but the text is actually in an image on the web page, and it's called Copyfish, and it only works in Google Chrome. So we'll have a look at that. If you want to use Copyfish after you've seen me use it, then you need to go to this this web page and add it to Chrome. I'm going to give you the link to it if you decide that's what you would like to do. And we'll have a look at doing that now. I do have a slide which goes through the details of what I've just viewed, just shown you on doing this with OneNote. And if you want to use that document that I was using, then this is the document here that I was using, the one that says https JSTOR.org. But I won't do that now because it won't work on my computer, and you can try it for yourself. let's go ahead and look at Copyfish. So I'll share this link with you so that those of you who are using the Adobe Connect viewer will be able to immediately add it to Google Chrome if you wish to, or you might wish to watch it with me first and then decide whether you want it or not, but I'll share that now. And if you're using the video version, you'll find it in the file with the list of links. That didn't work first time. Let me copy it and try it again. And it'll work this time. And if that has popped open for you, that's where, if you decide you would like to use Copyfish, you can install it. But for now, return to our Adobe Connect page that we're communicating in. And I'll move on to the next slide where we actually use Copyfish. I have it installed already, and so I don't need to reinstall it. So I'm going to use these two images on a browser to illustrate how Copyfish works. And I'll open both of those for myself and for those who are using the Connect browser, Adobe Connect viewer. I'll pause whilst, if I pause whilst I do that, then it won't open it for you. So that's the first one. And I'll open the second one. Those are for you to use once you have observed me showing you how to use them with Copyfish. So for the time being, if you can return to the Adobe Screen Viewer, Adobe Connect Screen Viewer, and if you're on the video, you can open those at your own leisure. Excuse me, and I'm going to share my screen with you. I'll share my screen. And I'll look at this one first. Oh, it's actually the other one which didn't open. This one seems not to have opened properly, and so I'll try it again. Yes, it's opened correctly this time. I'll share my screen with you so we can look at both of these now. Please ensure that you're actually looking at my shared screen rather than at the window of that's opened up on your browser or Copyfish, because otherwise, if you're looking at that, you may not follow exactly what I'm doing. So to show you how Copyfish works, when you have Copyfish installed, then you see the little black fish at the top of your screen, and when you click on that fish, your screen grays out and text invites you to select your text to grab, and you drag to select it, and Copyfish processes it, and there it is collected as well as it can collect it, and you can copy it to the clipboard, and it does a fair job at doing that. And if we look at Microsoft Word, I'll just open a web page and drag it in here and paste it in to see what we've created. That is what is copied. It's not perfect, but it is fairly good. And for students who are slow at typing, it is a boon, a great help, rather than transcribing. Let's have a look at this other one, and that is a large billboard that's at an angle. And just to show how effective copyfish can be, I select copyfish and select it, and that one it has been able to make a perfect copy of, or perfect text extraction of. That is copyfish, just a brief explanation of it. Another means of extracting text from images if they are on the web. We'll move on to the, sorry, I'll invite you to pause. I'll invite you to pause at this point and experiment with copyfish yourself if you wish, and then we'll move on. I see that my video has in fact frozen, but there is only a small amount left to do, and so in this first segment, and so I won't bother unfreezing it. Moving along. This section is on using Microsoft Word to remove new paragraph markers from OCR. I don't think I've mentioned before, but that part of what we know from what John Sweller's work is that I shouldn't do that. If there is text on a PowerPoint slideshow or other text on the screen that I expect you to read, I shouldn't read it to you at the same time, because what I'm doing is what I described as the problem with having students do read along, where the one process works faster than the other. I should allow you to read it at your own time, in your own time, at your own speed. And so instead, I'll invite you to read that heading, which you've already done. And then I'll explain it. And the easiest way to explain it is actually to open Word and to copy into Word the text that we extracted in OneNote. And so I'll share my screen and show you that. That process is in the next slide, so I'll move to that slide. And here is the text that was extracted on the top left-hand side. It's the actual text that was extracted from OneNote using that image that we saw earlier on. And I have that text now in memory. It's text I got from the computer that I was successfully able to do that text extraction. And I'm going to use Word to show you something about that text that needs some reformatting. So I'll share my screen and show you the Word document, the empty Word document that I have open. And I'll paste that text into Word and turn on the Show Hide button. And what we see is that though OneNote was able to do a fairly acceptable job, a good job, a task of extracting the text, the only way it could treat the lines of text separated from each other is by inserting a new paragraph marker, which doesn't actually follow the meaning or the context of the text. It wasn't divided up. Each line was not a new paragraph. It was logically flowing from line to line. And how do we correct for that? Well, we use the fact that the way that context is terminated, or an item of thought is terminated, is with a full stop. New paragraph lines are a larger breakdown of content. We can't really know where the new paragraphs were intended, but we do know where the break in thought was intended by a full stop. And so we can replace those new paragraph markers with spaces and then use the location of the full stops to give it more meaning. And this is what we do. We select Replace, and we're going to replace the new paragraph markers, which are the cap and small p, with a space. Cap small p space, and replace all, and we end up with continuous lines. And now we know that the full stops are the end of a sentence. I could have used that word rather than thought. The end of a sentence makes more sense. And so wherever there's a full stop, to break the text up more, I'm going to replace it with a full stop followed by a new paragraph. And by doing that, I probably haven't achieved what was originally intended, that is to create paragraphs out of connected concepts, but I have made the text meaningful and readable. If I've been left with double spaces, as I have here, I can simply do a generic replace of all double spaces with a single space. I can do a find. It's not that one. It's a replace space with space. And that's corrected that problem. So I wanted to show you that in case you weren't familiar with that process, and which you will find necessary if you do have legacy documents that you are going to use OneNote to extract the text from. I'll finish sharing this and move back to our Adobe Connect. And if you wish to experiment with that, please go ahead and then continue with me. I'll move on. And we've reached the end of this section, the major one, which is Azure's text-to-speech. And it's a look at the pedagogy with text-to-speech. How do we go about using text-to-speech in our teaching? And I really only wanted to discuss the first one, John Sweller's work, because the others you would probably want to discuss with your colleagues and think about yourself to see which of them are relevant to you. But this is what we have discussed, what I have discussed about John Sweller's work, the importance of how to use the knowledge of how working memory works in having students read with or without a voice, and use the knowledge that cognitive overload can happen if the voice is badly paced, and we should pace the voice to enable the student to gain the most from read along, because if the voice is correctly paced, then read along with audio whilst reading surpasses either or reading just using the audio or just using the text. Other than that, I'd leave you to examine the other areas of application that I thought of, and if there are others that I deduced from the research, and if there are others that you think of or areas where you've decided you will use it, I ask you please let me know, as I would like to include that information in future versions of this workshop. So that's the end of part one, and you will be able to continue with the last section with part two, which is shorter than this section.